We continue Unit 3 with Lesson 7, Slope of a Linear Equation. In this lesson, your objectives are that you can find the slope depending on if you're given a table, a graph, an equation, or 2 points. So we're going to be looking at all 4 of those. You can interpret the meaning of slope in terms of units stated in the data. And finally, you can define rate of change. So let's go over again what it means to say the slope. Slope is, the definition is a ratio of vertical change or rise to its horizontal change or run between 2 points on a line. Slope is sometimes also called the rate of change. Slope describes the steepness of a line in a coordinate plane. You can measure a slope of a hill, a mountain, a road, or a roof. Remember that there are 4 types of slope. Positive slope, going uphill. Here we have a ski bird. But you can also remember this with my example of if you write your name on the line. Oops, let me try a different color there for you. If you write your name on the line and the line goes uphill, then it is a positive slope. The opposite would be a negative slope, or going downhill. When a line is horizontal, we say that it has a 0 slope. Here we go, ski bird can't go anywhere because he's just level with the ground. But a vertical line, eek, no slope. Vertical, or ski bird can't ski vertically. Duma waits for ski bird at the bottom of the hill. No slope, vertical, or undefined. Those words are used interchangeably, no slope or undefined. So finding slope, we're going to demonstrate how you can find slope if you're given a table, an equation, a graph, or 2 points. First of all, finding the slope from an equation. You can find the slope of a line in an equation by, if the equation is in slope-intercept form, you can identify the slope as m, the number in front of your x, often a fraction. If the equation, though, is in standard form, you will have to convert it to slope-intercept form and then identify your m value. So let's take a look at some examples. An example A, y equals 1/2 x minus 18. Which form of this equation is it in? It's in slope-intercept form, so the slope is simply the value in front of your x, or 1/2. Pretty easy. And this should be easy for all of these. If you look down, B is also in slope-intercept form, so your slope is equal to 2. C is in slope-intercept form, so your slope is negative 5/4. And D is in slope-intercept form, so the slope is equal to negative 8. Go ahead and write those in your notes, even though it's pretty easy, because another day later, when you're working on these, you might forget, oh yeah, how do I find the slope from slope-intercept form? It's just the number in front of x. So make sure you write that down in your notes. On the other hand, when the equation is in standard form, like in examples E, F, and G, all of these, you see your x term plus or minus your y term equaling your constant. Those are not in slope-intercept form, so you will need to convert those. You start off by moving that x term to the other side of the equation. So you write 5y is equal to negative 10x plus 15. And then you divide by the coefficient of y. Coefficient of y is 5, so we divide every term by 5. Therefore, y is equal to, a negative over a positive equals a negative. 10/5 equals 2x plus 15/5 is 3. Your value that's now in front of your x term, or your coefficient of x, is negative 2, so that's the slope of negative 2. Try the next one. Same procedure. Move your x term to your other side of the equation by changing its sign. So 6y is equal to negative 3y. Not equal to, sorry. Plus 12. Divide every term by 6. Are you writing these down? Y is equal to then negative 3 over 6 equals negative 1/2. Don't put negative 2 down there. That's a common mistake. Remember, if it's improper, it will not turn out to a whole number. Oh, I did it again. I put equals instead of plus. Plus 12 over 6 is 2. So your slope is then negative 1/2. And that's not supposed to be. Wow. Doing all sorts of wrong here. That's supposed to be an x. X, x. If you're screaming at my screen right now, you're right. It should be an x. Alright, next, you need to move that 12x to the other side of this equation. So you have 24y is equal to negative 12x plus 36. Divide everything by 24. So y is equal to negative over a positive equals a negative. 12 over 24 is 1/2 x plus 36 over 24. That's improper. So it doesn't really matter at this point what that does reduce to right now. We could just leave it as an improper for right now because the question's asking just for the slope. We already know that answer. The slope is equal to negative 1/2. But 36 over 24, let's see, that reduces to, I can divide both of them by 6. So I get 6 over 4. I guess I could have used a bigger number than that. Let's see, what else can we divide by? Well, I went ahead and read out the factor pair so that I can make sure I find out what the greatest common factor is, which is, looks like to be 12. So it reduces to 2/3. Okay. Oh, sorry, not 2/3, 3 over 2, because the 36 is on top. 3/2. To find the slope when you're given a graph, you need to find 2 points on the graph that you make sure they intersect actual grid lines. Now, sometimes those points are given to you, but sometimes you'll have to find your own 2 points. This time they are given to you. It looks like there's a point here and a point here. And when I say they're on the grid lines, they need to actually fall, right where grid lines intersect. Let's go ahead and label those 2 points that we just identified. This one over here looks to be at -3, +1. And this one on the right looks like it's at 2, +3. Remember, your ordered pairs always have an x value and then your y value. You always count left and right before you count up and down. Which gets kind of confusing when you talk about slope, because slope is the rise over the run, or the vertical change over the horizontal change. So when you have 2 points on a line and you're trying to find your slope, you want to find your point that's on the left, and you want to know, well, how do I get to the point on the right? Regardless if your line is going uphill or downhill, because like a book, we read from left to right. Another way to help you to see which point you should start with is go ahead and write your name on the line, and where you started to write your name, that's the point that you're going to start with. Okay, so to figure out your slope, you need to first find the rise. So starting with your left point, how far up or down would you have to go to get to your next point? And this needs to be a straight line, not a diagonal. So in this case, we have to go up, looks like 2 units. So our rise is +2. If we had to go down, it would have been a negative number, or -2. Then our run, we should always run to the right. If you started with your left-hand point, you should always be running right. To get to my right-hand point, how far did you have to run? Looks like 1, 2, 3, 4, 5 units. So we had to run to the right 5. Slope is your vertical change or rise of, in this case 2, over your horizontal change or run, which is 5. Slope is a constant change from vertical to horizontal. If we were to count up another 2 and over another 5, we should still be on that line. So slope represents a constant rate of change. One of your definitions of slope. Let's practice these. Focus question number 1. We do this in 3 steps. Identify the rise. Remember, you need to start with your left-hand point, so our rise is 2. Identify your run, which is 1. Is the slope of the line going uphill or downhill? Well, if we write our name on the line, and also if you do start with your left-hand point and you're going to your right-hand point, you should always have the right sign here. So it's downhill. Or, I'm sorry, uphill. There we go, uphill. Therefore, we write this as a fraction. It's going to be a positive 2 over 1, or just 2 is your slope. Let's try another one of these. Focus question 2. Again, we start with our left-hand most point, and it looks like this time we're going to have to go down. How far down? 1, 2, 3, 4, 5, 6. So our rise, and you can think of it right now as it's going downhill, so it's going to have a negative slope. And our run to the right, 1, 2, 3, 4, 5, 6, 7. I counted 7. So therefore your slope is negative 6 over 7. Alright, do you see how to count slope now? I just noticed I was paused. Did you guys get this? It's a horizontal line, so it's not rising or falling, therefore the rise is 0. The run is 5, and any number, 0 divided by any number at all was always equal to 0. That's why the slope is equal to 0. If this was a vertical line, and you picked any 2 points on the line, it didn't matter what your rise is. Let's say we get 1, 2, 3, 4, and we didn't go to the right or left at all, so 4 over 0. Well, any number divided by 0 you can't do. If you try it on your calculator, go ahead and try it right now. Put 4 divided by 0 in your calculator, press equals, what do you get? You should get error, ERR, or something for that it won't let you do. That's because there's no slope for vertical lines, only horizontal lines, which is equal to 0. Alright, we found slopes from graphs, we found slopes from equations. Now we're looking at slopes from a table. When they give you a table of data points, these data points represent your x value or your y value, your input and your output. Remember that slope is constant. That means as one value changes, for example your difference in y's, your difference in x's should be at the same rate as you would go from one value to the next. Now I find this fill in the blank thing a little confusing. Let's go ahead and cross that off for now and just try this off to the side here. So to find the slope from a table, you just need to pick 2 data values from the table. And I know this is probably one of the most confusing parts of this whole lesson. Let's pick any 2 points here. Let's pick the first 2 and make it easy on ourselves. Well, as we go from 1 to 2 on our x values, what did we change? Just 1? Isn't 1 plus 1 just 2? Well, what do you have to change from to go to 260 to 520? Or think of it as the difference, so subtract. 520 minus 260 That equals 260. So as we increase our x by 1, we increase our y by 260. Slope says that this change should be constant. That constant rate of change of 260 feet per minute shows how much, if it didn't matter what the time was, you could just simply add the 260 for each minute. To prove that slope is constant, or the rate of change is constant, let's pick two other points. Let's say in 4 minutes, what is the rate of change compared to 1 minute? Well, our y value, the rate of change, if we take 1040 and we subtract the 260, what do we get? Well, 1040 minus 260, 0, let's see, 914, 14 minus 6, it's 8, 9 minus 2 is 7, so 780. And then 4, take away 1, is 3. Well, what's 780 divided by 3? It's still 260. It wouldn't matter which two rows we used if we subtracted the y's from each other and subtract the x's from each other and reduce, you will always get the 260. So the rate, or the slope, determined from a table is simply the difference of y's over the difference of x's. It doesn't matter which pair of numbers you use. So let's try some guided practice here, and as we're going back to your packet there and working on the guided practice, I did notice that I skipped over your opportunity to work on the practice on the slope, finding the slope of each line. So we'll do both of those. Let's go ahead, just because we just left off on finding the slope from a table, go ahead and practice those two problems down there at the bottom of your page. Push pause and then push play so you can check your work, and then go up and do the 4 practice problems and finding the slope from a graph. Push pause and push play so you can see your answers on those as well. So go ahead and do these 2 problems and push play when you're ready to check. Alright, you're either ready to check or you were lost and you just want to push play to see how to do one of them. Either way is fine. To find the slope from a table, you just need to pick 2 ordered pairs from the table. It doesn't matter which one you choose. I'm just going to pick 2 right here. It does make it easier when you use the smaller numbers or positive numbers sometimes. So I'm going to try those 2. So your slope is always the differences of y's. So you pick one y point and you subtract the other y point. We sometimes call these y2 and y1. If this is your first y point and this is your second y point, over x2 minus x1. So this is my second x point, this is my first x point. So you just work backwards. 9 minus 7 is 2, over 1 minus 0 equals still 1. So your slope, 2 over 1, equals just 2. If you want to check your work to make sure that you do have the right slope, just pick another 2 set of points, or 1 and another point. It doesn't matter. I can prove that that's the slope. Let's say I use the first 2 points. 5 minus 3 over negative 1 minus negative 2. Now this is why I generally say pick the positive points if you have any, because down on the bottom we're going to have a subtraction of integers. So that's always, people always forget you got to keep change on those. So 5 minus 3 is our numerator. That equals 2. And on the denominator we have 1 minus negative 2. Well, remember, whenever you subtract integers you have to keep change. So we have a negative 1 plus a positive 2. Those are opposite signs, so you have to subtract. 2 minus 1 is 1, and the bigger sign wins, so it stays positive. 2 over 1 is still 2. Alright, so it doesn't matter which 2 points, and they don't even have to be right next to one another. You should always get the same slope. So if you just needed that one as an example, go ahead and push pause again and try number 2. And when you're ready, push play to check. Okay, if you're ready to check number 2 now, again, it does not matter which 2 points you use, and please don't think you need to erase and choose a different point if you don't choose the same ones that I chose. I'm going to use 0 and 1 and 7, negative 7, so I have negative 7, oops, I wrote 4, negative 7 minus a negative 4 over 1 minus 0. So on my top I have a negative 7, because it's a subtraction, I change it to addition, then change my sign. Negative 7 plus 4 is negative 3 over 1 minus 0 is 1. So my slope is equal to negative 3. And that's what you should get for your answer. If that's not what you got, then maybe check your work, make sure you kept change if you had a subtraction, or try another 2 points to see if you get that negative 3 again. Alright, if you're done with those, then let's go back up and practice finding the slope from a graph of a line. And you could try all 4 of those, then push play when you're ready to check. Once again, if you needed me just to show you one as an example again, you could be doing that. If you are, then make sure you push pause after I show you the answer to this first one. Alright, so when you're trying to find the slope from a graph of a line, make sure you always start with the leftmost point. And remember that slope is the rise over the run. So our rise, or fall in this case, especially in this case, we have to fall down 1, 2, 3. So our rise is 3, or fall is 3. And because we're falling, you need to make sure it's negative. So negative 3 over how many? 1, 2, 3, 4, 5. So your slope is equal to negative 3/5. It does not reduce any further. Okay? So push pause if that was just, you needed that for an example. Otherwise, you can keep on going to check the rest of your answers. One thing that's kind of bad about these examples, there's been points already selected for you. I know on the test and sometimes on the ECA they don't give you 2 points right off the bat. You will need to locate 2 points. Let me see on this line here, for example. If those dots weren't already there, I would look up and down my line and see where the line intersects grid points. For example, right here is another spot where lines intersect grid points. Can you find any more? Maybe right, here. There's another point where it intersects grid points. Do you see, like, you would not choose this point right here because it's not intersecting both a horizontal and vertical grid point. Alright, using the points that they do give us, what's its rise over its run? Well, I have to rise 1 and go over 2. So that's your slope, 1 over 2. Just to make sure that that is the correct slope, you can use the other points that I just showed you before. Okay, we have to go up 1 and over 2. And so your slope is still 1 over 2. Maybe, let's see, if you didn't have your points, maybe you chose a point that was, say, here and one that was clear up here. That's fine. You should still get the same slope, because when you reduce, you'll find out that it is the same. So again, our rise in this case is 1, 2, 3. And our run would be 1, 2, 3, 4, 5, 6. 3 over 6, which reduces still to 1/2. And that's what slope is a constant rate of change. Let's look at number 3. What did you find out was your rise? Well, we found out it's actually a fall. We had to fall down how many? 1, 2, 3, 4, 5, 6. So negative 6 over how many? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Negative 6 over 10 is your slope, but you do need to reduce that to negative 3/5. And the last one. Again, starting at the leftmost point, and notice that the other point is below it, so we have to go down where it's a negative 1. And over how many? 1, 2, 3, 4, 5, 6, 7. Looks like 7. So your slope is equal to negative 1 over 7. The final way to find slope is if you are given 2 points. Let's think about when we were working with graphs and finding the slope of the graph. What you are actually doing is finding the difference, or subtracting from one point to the next. We did this when we were working with our tables as well. So to find the change in x's or y coordinates, you always have to subtract. Subtract, there we go. What number will you get in the denominator of the x coordinate if the x coordinates are the same? So that's the second question there. Well, if the x coordinates are both the same, for example, if you had 2 and 2, and they're the same, wouldn't you always get 0? So how would that affect your slope? Well, if your x coordinates are the same, and you get a denominator of 0, can you ever divide by 0? No. So this is a time when you would always have no slope. And even if you didn't see the graph, you would know that the line would be vertical. This subtraction is what we call the slope formula. The formula y2 minus y1 over x2 minus x1 will be located on a formula sheet for when you do take your ECA, so you do not need to memorize this formula. Even if you do memorize it, or if you can't memorize it, I'll show you an easier way later on that you can remember how to solve for slope using 2 points. So some important facts when finding a slope using 2 points. The slope is undefined whenever the x values are the same. Therefore, it's going to be a vertical line. You can save yourself a ton of time if you will always look to see if your x values are the same before you even use the formula. So if you get 0 for the denominator, then the line has an undefined slope, which means the line is always vertical. The slope is 0 when the y values, or the numerators, are the same, which then will create a horizontal line. So if you get 0 for the numerator, the line has a slope of 0, which means the line is horizontal. So let's take a look at a couple of pairs, ordered pairs here. Let's look at our x values. Are our x values the same? 9 and negative 6? No. By the way, did you remember when I say x values? Every coordinate has an x value and a y value, x value and a y value. And in that formula that we looked at before, that little 1 represents the first point and the little 2 represents the second point. So if you ever see a subscript next to a variable, that just means the first one and the second one. It does not mean times 1 or times 2 or to the first power or second power. Remember, exponents are up in the air. Subscripts are numbers that are down below and just helps you identify which one. So because our x values are not the same and our y values are not the same, we know that the slope of this line is neither 0 or undefined or no slope. So we can use our formula. The formula for slope is y2 minus y1 over x2 minus x1. And this is to help us solve for slope. So that's what m is equal to. When using this formula, notice that it is a subtraction, so we will have to do keep, change, change. To help you out with this, I have a helpful tip for you. Simply change the sign of the first point before you even get started. If we change that 9 to a negative 9, and that 11 to a negative 11, this will make it a whole lot easier. So our y2 value is negative 14, just write negative 14. and then it's supposed to be minus y1. Well, just write in your what we've changed it to, that negative 11, like that. And then the denominator x2 is negative 6, and write in the sign of your x1, so negative 9. This makes it a lot easier. You could just use your SOB rules. We have two negatives, so this is not multiplication. Use your SOB rule. Same signs add, opposite signs subtract, bigger sign wins. There's same sign, so we add 14 and 11 is 25, but the bigger sign wins, so negative 25. Over, we have a negative 6 and a negative 14. Again, those are the same signs, so you add. That's, what, 21? Let me think here. I might be silly. No, 25. There we go. Right? 19 and 6. Yeah. 25. So negative 25 over 25, that reduces, so your slope is equal to just negative 1. Alright, so simplify the fraction if necessary. Alright, let's take a look at another example. Again, first thing I would check is your x's and y values to see if they're the same. Our x's are not the same, therefore we do have a slope, it's not no slope, and our y's are not the same, so therefore we know our slope is not equal to 0, so we have to use that equation again. That equation is y2 minus y1 over x2 minus x1. Well, when you're doing this, if you can't remember the equation, that's fine. Watch the pattern that you're always doing. We're always taking this last number and adding its opposite over the last number and adding its opposite. Notice the little kind of letter that I'm making here, a big S, these two numbers over top of these two numbers, S for slope. So that's how you can remember the slope formula. Again, use my little trick, and I did it before. I didn't write the plus sign, I guess is what I forgot to do before. But the trick of changing the signs on that first point, it makes it a lot easier. So I'm going to have a positive 18 and a negative 5. Change it. Alright, so the slope formula says the differences of my y's, or 0 plus negative 5, over negative 17 plus 18. There, that way I don't have to really worry about that keep change. Now you can see on the numerator I have opposite signs, so I have to subtract, well, 0 minus 5 is still negative 5. Over here I also have opposite signs, so I have to subtract 1. The bigger sign is positive, so it stays a positive 1. Therefore my slope is equal to negative 5 over 1, which reduces to just negative 5. Right, ready for another one? Probably saying no. Alright, let's take a look at this one. Are our x's the same? No. Are our y's the same? No. Okay, so let's use the formula. Again, let's use our trick here of changing the signs. Negative 4 plus 12 all over negative 4 plus negative 8. It equals, okay, negative 4 and positive 12. Those are opposite signs, so I'm going to subtract. 12 minus 4 is 8, and the 12 is positive, which is bigger, so it stays a positive 8. A negative 4 and a negative 8, those are same signs, so I have to add this time. 8 plus 4 is 12, and 8's bigger and it's negative, so it's a negative 12. I do need to reduce that. You never leave a negative on the denominator of any fraction ever. So a positive divided by a negative is always a negative, and that negative sign should stay on top. 8 over 12 reduces to, let's see, both can be divided by 4. So 2 over 3. So our slope is equal to negative 2/3. Alright, let's try it. You have plenty of practice problems. When you're done, do look at your next file, and I have all of them together. But just in summary here, slope of summary, remember that the rise of a graph is how many units up or down you go from one point to the next point, from left to right, and your run is always to the right, from your leftmost point to your rightmost point. So in this example here, our rise is 1. The rise is 1, the run is 2. And they want to know what mistake did the student make by calculating the slope to be 2 on this case. Well, it's rise over run, so the answer for slope should have been 1/2, but they said they got a 2. What did they do? They put their run over their rise. So if you get a question like this, you'd say the student. This is a typical ECA question where they give you something that the student did wrong, this fictitious student, and you have to explain what they did wrong and how to fix it. The student incorrectly wrote the run over rise instead of rise over run. So our takeaways from this lesson after you finish your group practice and checking them. Slope is the rise or change in y over the change in x's. Linear equations always have a constant slope, which means the slope will be the same between any two pairs or points on the line. The sign of the slope determines whether the slope will be positive, or going uphill, or negative, going downhill. The magnitude, or steep or flat, will depend on whether the slope is a whole number or a fraction. Now, I didn't really explain that too well in the lesson, but a fraction is a number less than 1. So therefore, it's going to be flatter. If the slope is a whole number, then your line is going to be steep. A vertical line has no slope, or said to be undefined. And finally, a horizontal line has a slope of 0. A unit change in x produces no change in y, and that is when you move from left or right, the line does not move up or down. That's the end of the lesson.